Welcome back, and we'll continue with question number 4 from the thinking question set. So we have to find a second degree polynomial function which passes through the point with coordinates 2 and negative 1, has a slope of 0 at x equals 1 and a slope of negative 4 at x equals negative 1. So a lot of information provided here. We're going to start by writing down each piece of information and trying to interpret it in the meantime. So we have to find a second degree polynomial function. So that means we have to find an equation of the form y equals ax squared plus bx plus c. So in order to find the equation, it means that we need to find the values of a, b, and c. Now, we are given that this function will pass through the point 2 and negative 1. So what that means is that at x equals 2, the value of y would be negative 1. So that's the first piece of information. Now, it has a slope of 0. Now, again, whenever we say slope, it means derivative, which means that in our case, function y prime would be equal to 0 at x equals 1. So we're going to say that at x equals 1, y prime would have a value of 0. And the last piece of information here states that this would have a slope of negative 4 at x equals negative 1. So similarly, we're going to say that at x equals negative 1, the slope, or the derivative, will have a value of negative 4. So let's get to work. We have 3 unknown coefficients and 3 pieces of information that will help us determine the 3 coefficients. So I'm feeling optimistic here, because remember that whenever we have to find 2 unknowns, we need 2 equations. For 3 unknowns, 3 equations. For 4 unknowns, 4 equations. And when we say equations, we mean relationships between the unknowns. So let's start off with the first one. We have x equals 2, y equals negative 1. That means that negative 1 equals a, 2 to the power of 2 plus b times 2 plus c. So again, wherever you see x, we replace it by 2. Wherever you see y, you replace it by negative 1. So simplify, and that will give 4a plus 2b plus c. That's all we can get from this equation at this point. So we are going to box this up, and we're going to give it a name, equation 1. So at x equals 1, the derivative will be 0, which means that we now have to deal with the derivative of this function. So let's find the equation of the derivative. So this is y, so that means y prime would be equal to 2ax, and then plus b. So 2ax plus b means now that when x equals 1 here, y prime will be 0. So wherever we see y prime, we'll write the value of it, which is 0. Wherever we see x, I'm going to write the value of it, which is 1. And that will give us 2a plus b equal to 0. And that would be our second equation, which we are going to call it equation number 2. Now, the last equation, now very easy to build because we've already prepared the equation to use in this case. We are still dealing with the derivative. So y prime equals 2ax plus b. Now this time, y prime is negative 4 at x equals negative 1. So wherever we see y prime, we'll write negative 4. And wherever you see x, we'll write negative 1. So we have negative 4 equals negative 2a plus b. And that would be our third equation. This is when we start thinking the next step. Now, what do we do next? So remember, our job is to find a, b, and c. We created one equation that relates all 3 coefficients and 2 equations that relate only a and b together. So it will be the smart choice to use the last 2 equations to find the 2 coefficients. So because to find 2 coefficients, we need only 2 equations, which we already have. So let's go for it. So I'm going to write first the equation. I'll write them a little bit differently. So 2a plus b equals 0. It's the same thing, same idea. It's how you read it. So, and then the other one, I would actually take the 2a to the other side and b to the other side, and that will make positive 2a minus b. And then equals, so the negative 4, I'm taking it to the other side, and it will become positive. So the more positives in an equation, the better and easier to solve it. So as you can see, again, we have a system of equations. I'll use elimination here in this case because I have the terms, the b terms, ready to eliminate because they have opposite coefficients. So we can solve this by addition. So 2a plus 2a equals 4a, plus b minus b is 0, and 0 plus 4 is 4. So the value of a seems to be equal to 1, so we got a. Now we'll figure out what b is. We can use either equation. I like to use the positive equations usually, or the ones that have more positive terms, but it doesn't really matter. Again, either equation should be fine. So we have b equal to negative 2. Now that we've figured out the values of a and b, we can use equation 1 to find the last coefficient, the coefficient c. So we have negative 1 equals 4 times, we know a is 1, plus 2 times, we know b is negative 2, and then plus c. So negative 1 equals 4 minus 4 plus c. 4 minus 4 equals 0, which makes the value of c equal to negative 1. Now let's read the equation and the question carefully so that we make sure we answer the question asked. So we have to find the second degree polynomial equation, so polynomial function, or the equation of a polynomial function which has the given information, which means that we need to write the equation of the function at the end. So we'll say that the equation must be y equals a, which is 1x squared, plus b, which is negative 2 times x, and then plus c, which is negative 1. And in simplified form, obviously, we write x squared minus 2x minus c, and you do not have to write this step if you find it unnecessary. You just state the final answer here. And that's it for this question. And thank you for learning with me. And bye for now, and have a beautiful day.